Hey guys, I wanted to do a video on geometry concepts because these things are kind of unusual and probably pretty new for you. So we've got a few triangle properties and then some circle properties to investigate. So these are the practice questions that are in the hub and OneNote. And I am just going to go through all of the theorems that you need to be able to solve all of these questions. Okay, so triangles. So you probably already know that if you have a triangle, all of the angles inside of the triangle, so the sum of the interior angles will add up to 180, add up to 180 degrees. So if you know two of them, you can find the third one. And the other thing, two special triangles. One of them is an isosceles triangle. So these two sides right here are the exact same length. If we know it is an isosceles triangle, it usually has these little dashes to indicate that they're the same size, same length, and therefore we know that this angle and this angle will be the same. They will be equal, and that's for an isosceles triangle. And then we also know in an equilateral triangle, so if you have a triangle where all three sides are equal, then each angle will be the same. So since they add up to 120, 120 divided by 3 is 60. So each angle will be 60 degrees. That's for an equilateral triangle. Okay, so that's the triangle ones. I think that's all you need for here. Yeah. And then these weird circle properties. We've got this one. So inscribed angles subtended by the same arc are equal. And what that means is, let's draw a circle. I'm not in Notability, so I can't draw a nice circle, but there we go. If you have, let's just label 2 points on our circumference somewhere. So let's just say A, and we'll just put B here. If I connect A and B and use some other point on my circle, I can create two angles. So watch this. So I'll go up to this point and then back to B, creating this angle here. And then let me take another color. So like, let's say I tried a different location and I went up over here and then back to B. Now I've created this angle. It turns out if you do that, these two angles here and here are equal. They will be the same value. And it's saying, so inscribed angles subtended by the same arc. That part is saying this is an arc right here. So they have the same arc. So see how, let me just make this thicker. This brown line right here and this one, this is an angle that is subtended by this arc down here. And then if I take my other one, I go from here to here, and you can see it's the same arc. So even though they touch different points on the circumference here and here, they have the same arc, and so therefore their angles will be the same. So it may look different sometimes just depending on where points A and B are, but like let's put A and B really close. Let's say we have A and B, and let's say something goes like boom, bam, and then something else is gonna go like that. Well, we know that this angle and this angle are equal. So it may look totally different. I don't know. I'm trying to make a weird one, but I can't. Okay, let's say A and B. And let's say we go here and then here. And then here and here. So we still know this angle and this angle will be equal. So whatever they are, like if this was 20 degrees, then this would also be 20 degrees. Okay, so that's one theorem. Next one, the central angle. The central angle is twice any inscribed angle subtended by the same arc. So what that means is, let's draw a circle. So let's just pick 2 points again so we can create the same arc. So let's say we'll call this A and B again. And I'm going to say this is the center of the circle right here. That's the center of the circle, the middle. So if I create an angle by connecting these points, so now I've created this angle. If I create another angle, still using the points A and B, but not the center. So now let's say I just connect it here and here. And now I've created this angle. You can see that these are 2 angles that are subtended by the same arc. The arc being this right here. They have the same arc, but the green one goes through the center of the circle. And the black one is touching the circumference. So we can say that the green angle is twice the black one. So let's say this is 2x, then this angle would be x. Okay, so let me show you that again. So I pick like 2 spots on my circumference, anywhere. I also have the middle of my circle. One angle is created like that, and the other angle is created like this. So if I knew that this angle was 40 degrees right here, then I know the middle one here has to be 80 because it's twice that. Okay, so that's that theorem. And this is the arc. That's the same. Okay, next one. Angles subtended by diameter are 90. Oh yeah, this one's an easy one, I think. If you have a circle and you're going to put a triangle in it, but we're going to say the triangle, one of the sides is going to go through the center of the triangle. And then you can make the other 2 sides look like whatever, as long as they all touch the circumference. So any triangle you make, this angle will always be 90 degrees. So I'll just show you again. We're going to put a line right through the center of the circle, essentially making a semicircle. And then we're just going to make any triangle. This angle will always be 90. Like, so as long as I go through the middle, it doesn't really matter where I end up on the circumference. It's always going to be 90. 90. So you see what I mean? Anywhere you go, it's going to be 90. So that one's pretty easy. And then angles in a cyclic quadrilateral. Oh yeah, okay. So let's draw a circle. And make a quadrilateral. So just pick 4 points around the circumference. They can be anywhere. And you're just going to connect them so that you have a quadrilateral. And then let's label it A, B, C, and D. And this one's pretty easy. It's just opposite angles add to 180. So A plus C would add up to 180 degrees. And then B plus D would add to 180. So let's just try a question. So let's say you have a circle and you're going to stick a quadrilateral in it. Let's say you knew one of the angles. Let's say you knew this was like, I don't know, 105 degrees. So you're now all of a sudden able to find the one opposite because you know they have to add to 180. So this angle must be 75 degrees because 105 plus 75 would be 180. What else? I think that's all of them that I wanted to show you. Sorry, I'm just thinking. Okay, so you can, actually, I'm going to stop the video, but I'm going to make another one that goes through how to answer these questions.